This video is for trigonometry, and we're talking about triangles and sort of what the angles relate to which, okay? And how to look for which sides relate to which and all that sort of thing. Just some triangle rules, some basic triangle rules, okay? So first I'm going to start off, what is a triangle? Well, we have triangles that look like this, and we're going to call this, pardon my drawing, pretend it's a beautiful equilateral triangle. That side, and that side are equal, okay? And from now on, if I draw a line through a side, this is denoting which sides are equal. So each side that has one line is equal, or if I did this, and I went like this, then the two sides with one line would be equal, but the one side with two lines would not be equal to those, okay? So that's just sort of a basic triangle standard of drawing things. In physics, you only need to worry about right angle triangles. So what is a right angle triangle? So triangles are anything with three sides. A right angle triangle says one of the three angles has to be 90 degrees. Okay, so we could have any triangles, could be equilateral triangles, right angle triangles, triangles with two equal sides with right angle, one with two different sides, right angle, or you can have one that's not right angle and definitely still has three sides, but you have no idea what the sides are. So in physics, we only need to look at these two cases. Okay? This case here, don't worry about it. This case here, don't worry about it. Or if you see those cases, try to see if you can break them down into one of the two right angle triangles. Okay? Anyways, let's start looking at this right angle triangle here. This one, we're going to say a right angle triangle needs a 90 degree. Okay? But now let's pretend we're just looking at this triangle and we're saying, what is it made of? Well, let's try to imagine a second triangle here, which means that this would also be a right angle. Well, if you just look at this new red line, the outer perimeter of both triangles, what is that? It's a rectangle. So right angle triangles are basically just rectangles divided diagonally. And so basically what you can do is, in this case, our rectangle, since it's a rectangle, it needs to have all four sides as right angles, right? If all four sides are right angles, all four sides have 90 degrees, okay? And another option for what our triangles could look like are equilateral with two sides the same, okay? So not equilateral, but where two sides are the same, but it's a right angle. In that case, what does the red look like? Well, the red outline goes outside the perimeter of both. Yeah, that's right. It's a square. Okay, so it's a square, which means all sides are equal, right? In a square, all sides are equal. The rectangle, two sides are equal, the two opposite sides, and the other two opposite sides are equal. Okay, so here, two sides and two sides, whereas in a square, four sides. Okay, so that's one way of looking at it. now let's sort of jump into our square. Let's jump into the rectangle, because the rectangle is the more complicated one. So we have a rectangle that looks something like this. And each corner is a right angle, okay? And somehow, there you go, something like that. So the diagonal line goes from corner to corner, and there's a triangle on either side. Do you see this triangle and this triangle? Okay, there's a triangle on either side. Now, each of the triangles don't necessarily have, they have one right angle, but the other angle here, let's call this theta, is not a right angle. It's smaller than a right angle. It has to be, because a triangle is made of 180 degrees, which we're going to look at in a second for why. But it has to be smaller than 90 degrees because there's another triangle beside it, okay? This is the triangle beside it. But we know that this angle theta and this other angle theta somehow add up together to make this right angle in red, okay? So somehow 90 degrees equals theta plus theta, okay? Now, let's look down here. Well, let's just remember that, we'll remember for now, but we're going to look at it more in depth. 180 degrees is the total sum of all of the angles. So we're going to call it angle net for a triangle, okay? We're going to talk about it in a second why, but let's say it's true. So if it is true, then let's look at the top triangle here, and this one here, and let's try to look for this angle theta down at the bottom corner. Well, we know that it has 90 degrees, so we're saying that angle theta equals 180 degrees minus 90 degrees minus theta, okay? Does this make sense? So 180 is the total, minus the 90 minus the other angle equals blue. Okay? And I'm going to say that, well, let's stick with a different color for now, because you don't necessarily believe me in what I'm going to say here. But this is always going to be true. So let's go with, this is going to be yellow from now on. There. Just in case you don't believe me. So let's say that this is true. Let's plug in our old equation. So this 90 degrees equals theta plus theta. That's from inside here. Okay, let's plug that in. And we'll plug it in for the green angle. Okay, so we first have to solve for the green angle. So the green angle, I'm just going to write it all in green here because I'm lazy, equals 90 minus theta. Okay, let's write this in. The 180 degrees minus 90 degrees minus, now our new thing is 90 degrees, but we actually have a bracket here, right? So that we make sure we do this right. Minus theta. Okay. And this is still theta. Now, well, let's FOIL this in here. Okay, so this is minus 90 minus theta in blue. And this is 180 degrees minus 90 degrees Okay, so let's take a look at just the numbers. Let's cancel them all out. So 180 minus 90 is 90 minus 90. So actually, we know that this will cancel this will cancel this. Wow, so our yellow angle equals our blue angle. So I'm going to draw this in blue. So actually, if we look at any two triangles like this, where they make up a 90-degree angle in one corner, if you put them together, then the opposite corner rule applies. So this angle is equal to this angle, and this angle here is equal to this angle. Isn't that cool? So, what if you don't believe me that every triangle makes up 180 degrees? Well, let's do the inverse of this. Let's just think about it. Let's not write anything down, but let's think about it. If this opposite angle rule is true, okay, then, and we know that in the corner, top left corner, blue angle, like this, blue angle plus green angle equals 90, then blue angle here plus green angle here must also equal 90. Okay? So 90 plus 90 equals 180 degrees. And we've come full circle. There you go. Now, hopefully, you believe me. There are a few triangle rules, and this is how you start looking at triangles, by breaking it up into either a square or into a rectangle and sort of making 90 degrees in different places. Once you have those 90 degrees, you can start making things equal to each other. And not only that, let's look at the sides, but if it's a rectangle, this side here must equal this side here. And this side here must equal this side here. Isn't that beautiful? And if you know that the angle is 45 degrees here or here, then what is it? It's a square, right? Because it's divided in half. It's 90 divided by 2. So then you're looking at this situation, and in that situation, all sides are equal. Or you can look at it, if you have a right angled triangle with two sides equal, then you know that its opposite triangle is also going to have two sides equal. And not only that, those two sides are going to be equal to the original two sides. There you go. Those are some triangle rules for trigonometry.